All right, so here we're doing problem, where are we at now? 4.5, I believe. 4.5? Yes, it is 4.5. Thrilling problem. Okay, so we have v infinity plus, so entering, that is equals to 2.51 kilometers per second. We have an altitude at perigee of 350 kilometers, and then a radial distance when it leaves of 42,164 kilometers. So in order to do this, to find the time of flight of this, we're gonna be negative a cubed divided by mu square root of this times e sine hyperbolic of f minus f, everything in radians. Make sure of that. Where f, well, I just say sine hyperbolic of f is equals to e squared minus 1 square root sine of f divided by 1 plus e cosine of f. And f can be simplified as natural logarithm if you don't have hyperbolic sine on your calculator. I have it on my computer, but you might not have it. Of sorry, I was saying hyperbolic sine of f plus 1 plus hyperbolic sine of f squared. All right. And then another way we can do this is that tangent of our trigonometry divided by 2 is going to be equals to e plus 1 divided by e minus 1 square root of this tangent hyperbolic of capital F divided by 2. So many ways to find our f. Whatever we want to do, it's gonna get done. Anyhow, yes, so we need to find the clearly an e at some point, and we also gonna need to find an a, as you can see in here. So let's start by finding the a. So now we know that the energy is conserved for our system, and the energy when the object comes in is going to be v equals infinity divided by 2. It's very similar to 1 half mv squared. In this case, it's specific energy, so we have no mass. And of course, it's just a value, but it's also equals to negative mu over 2a. Therefore, we can rewrite this as these two cancel out. A is equals to negative mu divided by v infinity plus squared, or v infinity, because it's the same on both sides. I don't really care if it's entering or exiting my orbit. In this case, the entrance velocity and the exit velocity will be the same. So not really a care in the world for that. Then we have radius of perigee, which is going to be equals to altitude at perigee, we said, plus RE, where RE is the radius of the Earth. We can find, what do we need to find? We said, oh, E. So because we know that RP is going to be equals to EA times 1 minus E, therefore we can rewrite E as RP divided by E and 1 minus this. Right, let me see, RP divided by E, move to this side, I get a negative 1 plus, yes. So this, you can find E in this way, and then we can find our uh, uh, our f in this way, and then if we don't have any tangent of f like that, we can find our f in this way, but at the same time we can find sine of hf to plug it in here thanks to this formula here. Now on my computer I do have the arc10 of parabolic arc10. Never thought I would use this kind of stuff, but here we are. Okay, now we set altitude at perigee is equals to 350 kilometers. The radius of the Earth is 6,371, 78, whatever you want to use. Mu is equals to 3.986 on 10 to the power of 5. And we have, what else do we have? Oh, V infinity is equals to 2.51 kilometers per second. Oh, and then we have the final R is equals to 42,164 kilometers. Then we can find A by doing negative mu divided by, we said, V infinity squared. And then we do E is equals to 1 minus R at perigee, which I haven't calculated yet. RP is equals to alt RE plus alt P. Yeah. Okay. So I found A and E. Now I can find my F. Now F will be equals to 2 times the R and H, beautiful, of E minus 1 times E plus 1 square root of this times tangent of F divided by 2. Time from perigee, of course my perigee here, F will be 0 to the time that it leaves. We haven't found the angle at where it leaves, so we can find it because we said R is equals to P divided by 1 plus E cosine of F. F where it leaves. We know we have E, we have R, we need P. P can be found with H very simply. Can we find H? No, but we can find simply P by doing A times 1 minus E squared. So we're going to do P is equals to A times 1 minus E squared. And now we have our stuff that we defined for S. So it's going to be cosine the power of negative 1 of 1 minus E times P over R minus 1. And all this stuff here. So I'm going to find F final, which is equals to, we said, R cosine, too many C's. We said of 1 divided by 8 times P over R minus R final, in this case, yes, times that. And then we go back to our this thing here. Now, what is tangent of 0? I'll be honest, I don't remember. I think it's 1, but I'm gonna just solve it. It is 0, yes, so everything goes to 0, so our F here goes to 0. I mean, I should have expected it. I don't know what I was doing. And then we have our second F. Our second F is gonna be the F final that we just calculated. So it's gonna be F, capital F is gonna be 2 times NP arc 10H. And P is square root of, on top we have E minus 1 divided by E plus 1 times the tangent of, we said, the F final divided by 2. And now we find the T minus this. So my TOF will be equals to the square root of negative A cubed. Did we find A earlier? Yes. Divided by mu times E times sine hyperbolic of F minus F. And let's print out the value. Divided by 3,600, so we print it in hours. And it's equals to 0.86 hours. I don't like it in hours now. I'm gonna do it in minutes. 51 minutes. It doesn't seem right. Let me make sure that my arc10h is giving me a value that I think is correct. So I have 0.65 radians for my F. It is positive. That's really all I can say about that. There's no way for me to check if anything else makes sense. Let me go back to my zeta here. So I have v squared divided by 2 equals to a negative mu divided by 2a. That should make sense. Yeah. Then E is going to be equals to 1 minus RP divided by A. That also makes sense. P is equals to A times 1 minus E squared. That's just the way things are. And final, our cosine 1 minus P divided by RF minus 1. F is equals to arc10 of E minus 1 divided by E plus 1 times, oh, that's why, because I put the square root that includes the tangent, or the tangent actually outside of it. 116 minutes. Yeah, there we go. So this is the answer. Some coding issue, but all the thought behind it was correct. And this is the code for it.